So welcome, and you made it. It is the last session for today. So my name is Hristo Borisov, and I'm director of product for a product that we're developing called Darvin.ai. And today I'll talk about declarative programming, which to us is the future of chatbots, AI, and cognitive computing. So I'll quickly start off what we see in the future. I mean, there are a lot of developer tooling and services available for developers today that promise you that you are going to build the next generation of apps. But this is how we are actually seeing the future of those kind of future apps that are coming. So in the future, software is going to offer you a unique experience based on your behavior. A lot of softwares today promise to do that, but what we imagine in the future is that it's going to completely change for each different individual users, and it's going to learn on the way you're using a different software, so that you have the best personalized experience, so to say. We're also not far away where a software will be trained like a human. With the goals and examples, where you are actually telling the software what kind of a goals and examples, what kind of a goals it needs to achieve, and you're going to give it examples on how it's going to achieve it, and then you're going to actually have a full-blown product. And of course, the benefit for the users and the premise is that there is not going to be a learning curve when a new user is using the software. No decisions to make, no different UIs to click. Pretty much you're going to, if you think about how people are using voice or chat-based systems today, they're pretty much just going and using them without reading a manual before that. So the whole hype about chatbots and AI and cognitive computing started with, this is the Gartner's hype cycle. So they're explaining with this graph how a technology is usually going through different cycles. So when we talk about chatbots, there was a technology trigger. A lot of companies started doing something called natural language processing, or NLP. So this is the place where you can actually use a set of services and pass it natural language, like just an example sentence in English, and it's going to return you some interesting entities and intents that you can use as a developer to go and create some kind of a smarter software. And the peak of the inflated expectations was that was March and April last year, when Mark Zuckerberg was on stage at Facebook 8, the Facebook Developer Conference, and announced that Messenger is going to be open for developers to actually build chatbots, use natural language processing, and build those kind of smart systems to interact. But what usually happens is that when you have this kind of inflated expectations, you actually go to the throat of disillusionment. This is the place where you actually realize that the dream that you have about the technology is not yet there, and the technologies and the software that you need to make them still have a way to go. So why is that? A lot of us have watched the movie Her, or AI, and many other films that are featuring this kind of artificial intelligence that talks about that is sensitive, super knowledgeable, very intelligent, and it can help you do many different operations with it. And when the chatbots were introduced by Zuckerberg, everybody imagined that people can simply go and talk to a chatbot and say, hey, for example, can I book a room for tonight? And the chatbot will be super intelligent and will know your preferences and will simply reply, hey, James, we have a room available for tonight. Here is the rate. But what happened over the last year and a half when chatbots were kind of introduced, and a lot of people started talking about them, and a lot of actually investments were made into that space. There are currently more than $4 billion of money invested into the chatbot space. And there are more than 306 vendors, according to the last survey by Gartner, of companies who are making some kind of a developer tooling for developers willing to build chatbots. So if you have interacted, for example, with a chatbot recently, your experience can be summarized something like this. Hey, I want to book a flight and a hotel for a trip to our headquarters for me and my manager on Wednesday. And the chatbot will be, sure, where do you want to go? Even though you said where you want to go. Then you're going to say, okay, I need to write Boston. When? On Wednesday. Sorry, I didn't get that. When? You need to put it in a specific format. And then for how many people? Okay. I meant actually 29th of March. And at that point, if you change your decision, usually you're going to get this. Do you want to start over? And the reason for this is because the majority of the chatbots today are built with decision trees in code. So what we see is that there are actually two major things that are limiting the companies to dive into AI and chatbots. The first one is something that I'm going to explain, and I call the Siri syndrome. And the second one is the lack of developer tooling. So what is the Siri syndrome? With Darvin.ai, we actually built a chatbot for a local hospital in Bulgaria that is allowing patients of the hospital to book doctor appointments by talking to a chatbot on Facebook Messenger. And till now, there are more than 300 people who went and booked their appointments for a doctor using the chatbot. But while we were doing it, and when we are actually reviewing the types of conversations that are happening, we actually saw a very interesting thing. Our ultimate test to check, are we there yet in terms of intelligence, when people talk to the chatbot and they see that it's intelligence, they ask it, what's the weather? So this is the way for us to go and ask and see how intelligent a chatbot is. And this is just one of the examples. A lot of people are asking, how much is 5 plus true? How much is, who is your master? Who are you? What are you? And things like that. So what we are seeing is that product leaders today are really stuck to think about knowledge bots that result in a multi-million project flops instead of transactional chatbots. And the difference that knowledge bots, we have this notion because all of us are using Siri. And all of us are maybe using Cortana or any kind of other knowledge bots that are promising to do many different things for you. The difference between a transactional chatbot and a knowledge chatbot is that a transactional bot is usually trained to do 4 to 6 iterations or operations, for example. Think, for example, what you can do when you call your bank on the phone. Maybe you can report that your credit card was stolen. Maybe you can ask for the local offices and the working hours of your local branches. You can maybe check the last transaction and things like that. So you have a very defined set of limited operations that you can do on the phone with an operator. And what we are seeing as a trend is that the majority of the people who are willing to build a chatbot, first, their notion is that, well, we want our Siri for our bank. But obviously, Siri is great, but Siri is doing 1,000 things. And building Siri is not viable for any company that is willing to join and build chatbots. And that's why we are actually helping companies build what we call transactional chatbots that are be able to augment and replace an expert in 60, 70, 80% of the time. But sometimes, and the majority of the time, you still might need to have a real person to take over the conversation if it is in a different scenario. So thinking about this and thinking about transactional chatbots, we're seeing a much better return on investment. And there were a couple of examples of knowledge chatbots that were given, that were visible on the market. One of them is Ibm Watson. So Ibm Watson created $60 million deal. They made a deal with healthcare institution in the States to actually create a chatbot that is going to able to assist doctors when making decisions about cancer. And in reality, what happened is that after 2.5 years of integration and spend, the company ended and communicated outright that they're actually giving up from the project. It is able to correctly, provide experts with an answer 90% of the time. And when you have something like this, a bot that is doing so many complex operations and just works 90% of the time, people are still not happy with it. And that's why what we are, for example, have created with Darvin.ai is much more about the transactional bot. And here is an example of one that we're going to show you in a minute. That is trained for a bank to negotiate, debt, to actually negotiate bad credits for the bank. So if you, for example, haven't paid your mortgage, the chatbot is going to, talk to you and try to negotiate either a down payment that is less than your usual installment, or help you change the date. Another one, of course, is if people would like to find the branches and the ATMs that are working. This is also a very suitable example where a chatbot, instead of calling an operator and waiting on the line to get that information, might be useful. And this is what we are actually advising the majority of the companies that we work with to really consider what is their idea about, what they want to optimize and how they want to optimize it. Because if they simply say, I want my Siri or I want my Cortana for my bank, this is going to really drive the conversation in a different direction. So this is what we call the Siri problem, and the way people are currently testing whether chatbot intelligence is there. But when you are actually working with a very specialized chatbot doing something, usually when you call your doctor to book an appointment, and midway through the conversation, you never ask what's the weather, unless you're searching for some kind of mental health care services around. The second thing that we're seeing outside the Siri syndrome is the developer challenge. If you saw the demo in a minute, the actual conversation that I showed you, it pretty much exemplified what's the issue with the chatbots today. The majority of the chatbots today are built on top of decision trees. And the intelligence of the chatbots that they're using today are limited by predefined paths by developers. And here I'm going to tell you an internal story that we had a year and a half ago of an internal project at the company. Which was called the Progress Virtual Assistant, but is still in use today. So the Progress Virtual Assistant is a chatbot that we built actually on top of a native script app that allows employees at Progress to book meeting rooms and schedule meetings with colleagues at the company. So the chatbot is connected to Outlook. It knows all the people in the company, all the rooms, so you can go and intelligently talk to it, and it's going to really help you go and schedule this meeting. So when we started building Darvin.ai about a year ago, we met with the developers and we interviewed them to understand what kind of challenges they had when developing those chatbots. And the team was pretty clear. They said, well, it's actually very easy to build a chatbot. So the first thing you need to do is go and define all the different ways a conversation can start. So if a person starts with, hey, I want to meet with Georgi tomorrow, or if he says, I want a meeting for 1 hour, or if he says, can you schedule a meeting in a specific room for me? The conversation can start in many different ways. And what the guys did is actually created on top of a natural language processing provider. They created this kind of a decision tree inside of code. So this is .NET code behind the scenes. And then they said, actually, once you do that, the next step that you have to do is actually allow the user to change his intent and his preferences at every point in the conversation. So if the user said, well, I would like to meet with a specific colleague, for example, and for 1 hour, and then he changes his mind and says, I actually want to increase the meeting to an hour and a half, you need to provide this kind of buttons and options for the user to actually go and navigate there. And now you can imagine this is their V1 that they built for about 4 months. That is, very impressive. But actually, the guys spent all the time to actually develop this on .NET and code. So the challenge today is that creating a chatbot, even if you're using some kind of services from Azure or Amazon, or Amazon, or for example Facebook for natural language processing, you are still left to go and create the conversational intelligence in code. And this is obviously costly to maintain and develop, and is quite error-prone. So with Darvin.ai, we actually decided to take a completely different approach. We talked about the future of cognitive computing, and we got to the conclusion that if you're actually creating any kind of a service that has anything cognitive or intelligent inside of it, you need to actually use a different approach. You need to tell it what you need, what you want to happen, not how. How is the way you do it with code, and writing imperative code like .NET or Java or JavaScript. And what we actually did is actually created a way to actually do declarative programming, where you actually describe what needs to happen. We actually estimated that 90% of the budget for a transactional chatbot is spending on those conversational intelligences. Trying to make this decision tree intelligent and be able to react in all different situations. Be able to change the intent and all the things that the user needs to do needs to happen, and is happening in code. So what we're introducing on the market is something that we call the cognitive flow. So this is our feature, so to say, part of our product that allows you to do these decorations and just say what you want to happen. So to give you an example, if you're a developer building a chatbot for a hospital, and the first thing you want to do and you're given to do is a conversation that helps people book an appointment with the doctor. So there are a couple of things you need to get from a conversation. You need to understand who is the doctor from the hospital. You need to understand what date, what is the time, what is the phone number of the patient that is willing to book the appointment, and what is his name, for example. And this is a way where you're simply saying those things to Darwin, and we're actually taking care of having the conversational intelligence for you. So the declarative high-level programming language to create cognitive conversations is what we actually do with this. And the approach is the following. You actually go and define, as I explained, the goals in the conversation. The goal is obviously a person to book an appointment. A goal can be a person to contact an operator, or a goal can be to just do a quick survey with the patient, let's say 2 hours after his appointment. You have a way to train the chatbot on top of natural language processing so that it understands who are the doctors of the company. When you say Hristo Borisov, for example, that it understands whether it is a doctor in the company or it's not. To actually help it understand different intents when people would like to contact an operator versus booking an appointment versus canceling an appointment. So you provide a couple of sentences in natural language to the chatbot so that it can learn from them. And you actually let the cognitive flow take care of that. And this approach has proven to be 15 times faster and 2 times cheaper than everything that's existing on the market today. We have tested this with a set of chatbots that were done with a competition with some of our competitors out of the 306. And the difference is quite big. I mean, it is just different. And I'm going to show you in a minute. So to actually show you a chatbot in a conversation, here I have an example of a person talking to the bot to book an appointment in English. So I will try to play this one from here. And if it doesn't want, I will jump on Chrome. So can we switch to Chrome here? Maybe I need to exit from the presentation. Sorry. Okay. So I will start it and pause it so that you can actually see. So a person starts with, hey there, obviously. I would like to meet with Dr. Burke on Wednesday. And the chatbot is going to say, okay, Wednesday is obviously this date, and Dr. John Burke is available at this time. And then the user can say, can I check the schedule of Dr. Oakut? Quite good name for a doctor. And here are the available hours for this doctor. And then you can, either tap on those. Those are quick menu replies. And then you're going to go and give your personal ID, phone number. And at any point, you can just say, well, I made a mistake. Can I change the doctor? Can I do this? Can I do that? And it's going to actually go and help you with the appointment. For example, for Dr. Sterev Hospital, we are also reminding people an hour before their appointment so that they don't forget. The second example I want to show you is about debt collection. So this is a chatbot that banks and financial institutions will be using to actually go and try to make better payments and collect payments. So a conversation can start with, hey, I had a missed call from you. I'm a financial advisor at Citibank. What would be the most appropriate time to talk about your mortgage? Obviously, can we talk later? What is the day that is most convenient for you to talk about this? And the user can say next Wednesday or 12th of August and things like that. So he's saying next Wednesday would be great. And obviously next Wednesday, when I recorded this demo, was 8th of November. What time? 10:30 in the morning, please. And now the chatbot is going to say, OK, I'll contact you on that time so that we can have the conversation. But you can say, oh, wait, let's talk now. Let's see, I'm curious to see what's happening. You're 15 days left to your last monthly mortgage payment of $2,000. What is the payment you can make by the end of the month? And the user is saying $45. Well, you can make a minimum of 200 and a maximum of the actual payment. What is the amount you can pay by the end of the month? OK, let's try again. 205. Sounds like fair. What was the reason that you were late? Can you describe it? I was sick. Well, you need to elaborate this more. I need to justify this. OK, I was sick last week and couldn't go to the bank. To the bank. Are you behind any other credit card commitments? No. Credit commitments? Our bureau data indicates that you have an overdraft of 10,000. So this guy is really in trouble. Can you pay an hour delay? Our delay payment? Well, what is the time that you're going to make the installment? Let's say November 15. And the chatbot is going to be, OK, we expect your partial payment of $255 by that time with this reasoning. We will remind you the day before. So this is just an example that we built in a couple of hours with Darvin.ai, building, integrated with an enterprise system to actually pull this information from. So this is an example of a chatbot. So let's see how those chatbots are actually built. So the first thing is our cognitive flow. So the cognitive flow is the place where you are actually defining all the different conversations that your chatbot supports. So for example, in the last one that we saw, we have a conversation that's about contacting you later, a conversation about starting a conversation now and negotiation right now, a conversation about delaying payment, and conversation about paying right away. So you're actually going to, you have all the different conversations in a JSON format. This is how you actually declare what are the steps and what needs to happen. And then you have the different steps that need to happen. So a step can be either you ask a question to get some information from the user. It can be a message so that you pass some message to the user. Or it can be a webhook. If you need to retrieve some data or persist some data in external systems, you can use those. Then you actually have to train the NLP, which is happening pretty fast. So you have a couple of ways to train the NLP. You can do a static manual train. So you go and say, OK, I have an entity. Let's say the type of doctors are just two. And they're either a general practitioner or some kind of other doctor. You can type those right away, or you can actually put them dynamically from a web service. If they are more than, let's say, 5 and 10, and they're frequently changing, you might like to go and get this information from an external system. Then you have different lookup strategies. For example, with the natural language processing, you have the way to look up for a trait. So the trait is the general meaning of the whole sentence, what the user is actually willing to do in general. And then you actually can have a keyword. So in the example that I showed you when the person said, wait, let's talk now, the trait of this is to be talking now. And he can write this in many different ways. The help of the NLP is that once it is processing the message, it is actually telling you what the intent is so that you as a developer can use that. Then the keyword, so the name of the doctors that you said, Dr. Oka, Dr. Burke, John Burke, and things like that, those were the keywords so that we can identify a specific keyword and a synonym inside of the text and retrieve this back to a system. And then you can, of course, have a regular expression. So if you're looking for a license plate in the text or any kind of a credit card, you have the way to do it. And once you do that, you can simply go and publish your chatbot from the channel. It is that easy. So let's actually go over an example so that you can see a definition and how a chatbot is being created. So here, as I said, the declarative approach is focused on goal-directed flow. So the goal of our conversation is going to be a webhook. So we want to make a webhook request to an external service, we would like the message to be, congratulations, you have an appointment with doctor, title, first name, last name, on a specific date and time. This is our goal. It has some specific condition and a data source, which is actually the action that is going to happen with the webhook. So this is the way that you start. You say, well, this is what I want to happen in the end of the conversation, right? And then this is the data source expanded so that you can see it on the second screen. Here, for example, we are calling a service, and we are saying, hey, this is all the information I want to store in the external system. I want from the doctor ID, I want the ID of the doctor, contact, identification number, phone, and things like that. And you can notice that here we're using the dot notation. The reason why we're using the dot notation is that once a person once the chatbot identifies, let's say John Burke, it's going to return you the whole object that contains all the properties that it learned from your system. So when you're training the chatbot on top of your system that you're going to see in a minute, we're actually storing all the properties that are available for this object, and we're giving you the context. And the same is for a user. The next step is that obviously we are talking about some kind of a doctor here. So when we see that there is such a dependency, you need to go and describe the possible steps. So you have to say, okay, if you're going to talk about a doctor, I want the entity to be a doctor. It is something that we have already trained in the NLP. I'm going to show this in a minute. If the chatbot needs to ask about the doctor, this is how it's going to ask. What is the name of the doctor that you want to see? There are a couple of interesting things here. Since asking for the doctor might require, since actually persisting the information requires date and a time, here we are also describing a date. And here in the date, you can see that what date do you want to meet with doctor, first name, last name. And since this has a dependency on the doctor, we're never going to ask about the date first, then the doctor. But if the user says, well, I want to meet with the doctor tomorrow, we're going to know that it's about tomorrow. We're going to ask about the doctor, and once we know the doctor and we know the date, we're going to make a validation whether this combination is actually logically possible in our system. So this is a way to define the different steps. And we also have something that we call reactions. So you can see here that there are different reactions: acknowledgement, ambiguity, and validation. And those are needed for different scenarios. So for example, if you talk to a chatbot and you say, I want to meet with John Burke tomorrow, it is a good practice that the chatbot is going to tell you, well, I understand that you want to meet with a specific doctor on a specific time, so that you know that the chatbot understood you. Otherwise, you're going to just see a set of questions, and in the end, things might work, might not work. You need to have the confidence, like as you are talking on the phone with a person, when you are speaking about a name, the person is obviously confirming that he got the name. And that's why the acknowledgement is used so that the chatbot can say, if it didn't explicitly ask you about this, it's going to say, well, I understand that you want to meet with a specific person. So here we have expanded it. I'm not sure I understand, sorry. Here is the ambiguity. I understand that you want to meet with a specific doctor so that the user knows that the bot understood him. And the ambiguity is used when the user says, well, I want to meet with Dr. Burke or Dr. Okat. And the ambiguity is going to be used to decide which of the two entities you actually want to get. The next reaction that we support is validation. So validation can be a custom validation like here. So you can use the information that you have gathered from the user, call an external web service, and print an error message and say, well, actually, this doctor is not available at all, for example. This doctor, for some reason, is not available. This is an example. But the validation can be a number validation, a range validation, a length validation, email validation, and things like that. So once you define your cognitive flow, you also have a control to allow how how the information can be displayed to the user. So when you are defining a step, for example, choosing who is the doctor, you can simply say, well, I would like display to be quick reply. And the quick replies are these small bubbles that appear inside of the conversation. So if you say quick reply on an entity that is doctor, we are automatically knowing that you are willing to provide a better UI for the user, and we are automatically going to provide the different information for the user. For example, you can actually do single select, a little bit more advanced scenario, where, for example, you want a template where the user can select from first name, last name, see a picture of the doctor and his title, and you can actually, on the very same definitions that we have done, you can just say, well, actually the display to be single select. And here we are going to actually change from the bubbles to a choose a doctor button, where you are going to actually get inside of the chat this much better UI, where you can actually see the names of the doctors, click on them, and select them. We also support things like pickup a location. So if inside of your conversation within the chatbot, a possible scenario might be that you would like to get a location of the user so that you can provide him information with that. You can just say, well, the user can select a location, and then the user is going to click on a map, select where he is, and send the location back. And this is working for all the different channels that Darwin is supporting. So we have Messenger, Viber, and a native website plugin that you can use on your website as well. So the last couple of things I want to actually show you are inside of the Darvin.ai portal. I will show you how a training is done quickly on top of a web service so that we can actually see the actual training as well. Okay, so let's go to, let's actually create a new one. I know some of our devs here are a little bit nervous. Okay, I'll actually create a new bot. Seeing the guy smiling. The reason why we are smiling is because we are using actually a Facebook natural language processing, and sometimes there, when you're creating a new chatbot, you need to wait about a minute or two, depending on the queue of requests that I have to actually process that. But hopefully, we'll hope that the queue is not that high, even though people are waking up in the US right now. So this is the cognitive flow that I showed you a minute ago. So you have a getting started conversation, a contact an operator, book a doctor appointment, and those are all the conversations the user can have. Hopefully you can see that. So those are all the different conversations a user can have that. So for the booking a doctor, we have a step that is saying, hey, this is the doctor, this is the name, things like that. So if we get to that step, and if we need to talk about the doctor, the chatbot knows how to talk about the doctor. Here is how he talks about the date. How he talks about the time, asking about first name, last name, asking about the confirmation, and a webhook. And you can have very complex, logic inside of this, depending on the way you define the different steps. So if I go to the actual memory of the bot, this is the bot's brain, so to say, I can see that I currently have two conversations that are being trained. Contact an operator, where I have said, well, if it's going to be contact an operator, this is how people will talk about this. They can say, contact an operator, would you get me in touch with a human, forward me to an operator, maybe I'm fed up with you, for example. And all of this, the NLP is actually going to extract what is the actual meaning behind this, so that you can actually go and write something completely different in text. It's going to provide you and give you that. Also, we have a way to book a doctor, so you can write any of those. And over time, as people are talking with the chatbot, it is learning from the way they're using it, and it's increasing the way people are talking about this. So let's actually try it. Let's see. I want to meet with a doctor. Okay, now it is giving us 51% confidence that you want to meet with the doctor, right? But if we, for example, train it with this one and say, okay, this is one way to, book an appointment, and update this one. Maybe Facebook is with us today. Okay, now, because I gave it the very specific example, it says 99.44%, the chances that this person is talking about booking a doctor appointment. Now, if I click here, I'm going to see all the different doctors that are available on this. But I'll actually go and delete this so that I can actually show it to you how this is created. So, for example, in your system, you might have name of doctors or name of offices or anything that you want to actually have inside of the conversation. And you can actually go and do a dynamic training on top of this. So what I'm going to do now is I'm going to click on Add New, and I'm going to say doctor name, for example, is going to be the name of my entity. And I'm going to say instead of static, I want a dynamic training. And here I'm going to put a function that, let's see, okay, maybe, let's see, okay. Okay, I won't show this one. But it is just a collection. So if I click here, let's actually open this somehow. Maybe in downloads, no. Let's see, is there a way to put this one? Let's try Edge. It's smarter, faster. Oops, not there. Okay, here you go. So it is just some kind of a JSON file that contains the data. And what's interesting is it is very well aligned. So it is an array that contains all the different elements that I need from this. So when I say, I see here in the JSON that I have a last name and a first name. And here, once I retrieve the data from the web service, I'm going to say, well, actually, the friendly name of how people are going to talk about this object is going to be, let's say, last name. This is how people are going to talk with it. And here are all the doctors that we are finding in this collection. And if, for example, I can say, well, actually, let's make it a bit more user-friendly. First name, say like this. This is the way people are going to, for example, naturally say this. And you can define synonyms. For example, usually the last name of the person is a synonym for him. But sometimes the data that you get is not so well aligned. And here we have an example of a service that returns a little bit more of objects. So here we have a count, a result, and then the actual result is nested somewhere there. And if you're creating a chatbot on top of an existing systems, obviously you can get any kind of responses and payload from those REST services. So what we actually did is we are supporting JSON selectors. So here, if I just say this one, obviously it's going to return me the whole service, which is, I don't want this to be the user-friendly thing that the chatbot understands. So here what I can do is say, well, I want to get the results from this data. So when I click this, oops, sorry, should be like this. Okay, here we go. We're getting the names, but you can see that they're right now mixed because in the same service, we are supporting localization and we have both Bulgarian and English doctors. And here you can do things like this. Well, give me the results, but only where the language is BG, for example. And this is going to make actually a selector on top of the JSON data. And this is actually helping you, go and pretty rapidly go and connect the chatbot with the relevant data that you want. Instead of the usual way, if you are using any other system, you have to, first of all, go and extract the data and train it manually. And second of all, if you want to get and massage the data in the way you want, you usually go and write your custom functions, deploy your server, and it does the data transformation and return you the proper endpoint. So if I go and train it with the English doctors, like this is going to actually create our new entity. And now the chatbot should be able to understand, actually, let's say, to understand our new entity. Okay, it understands that it's a doctor, finally. And here you can also see, once we got the doctor, we have all the all the different data that was in the system. So at any point inside of the conversation, you can use any of these data if you want to populate it in any format or way. We also support, inside of the cognitive flow, we have a very strict JSON schema validation. So it tells you when you made the mistake or when you say, well, this is a not valid property, so that you can actually much easily go and define the actual flow. You have a way to test this. So if I copy this proxy, I can simply go on Messenger. Hopefully you're not going to. And say proxy. Now it's going to tell me that chatbot dev test is mapped, and I can simply say hello, and now I'm talking to the chatbot that I just created. This is Tiago. Okay. And now what we also support is history of a conversation. So if you have a chatbot out there, you like to definitely monitor how people are talking with it. So here I have an example of a conversation. So I'm talking. So sorry about it's in Bulgarian, this one, but it is simply showing a conversation between a user and the chatbot. And when you click on this, you actually get what kind of a context the actual conversation had, and you can actually see what kind of an understanding the chatbot had. So for example, here the user said, who is the nearest office, translated in Bulgarian, and the chatbot identified that it's looking for the nearest office with that confidence. Here is a webhook that was executed, so that you can actually go and much easily test and debug this information. When you actually go and define the cognitive flow, you want to make sure that the flow is happening and that the proper data is sent. So you actually have all this at your disposal. You can go and see that. You have analytics to see which are the conversations that were abandoned, so that you can go and see how to improve the chatbot. You can actually see situations where your chatbot did not perform well, so that you can train it with more data. Here are the different channels. You go and simply enable the different channel for the Facebook and Viber. You just simply follow a couple of steps to publish to your channel. And for the website widget, we are giving you a small snippet that you put in your website, and your chatbot is instantly there. So with that, I think I'm ready to do a quick Q&A. Just one note, I don't know what the weather is. So this is the final part of the presentation. So if you have any questions, I would be really happy to answer them.
So how do you implement the security? For example, with the bank example,
Mm-hmm.
the chatbot has a functionality to check your balance. What stops you from checking your balance?
So I didn't show it on this demo, but we actually support authentication. So for example, I'll show you an example where, obviously for this simplified version that I showed you, there is no authentication. But actually, you can actually do an authentication inside of the conversation. So I'll show you an example of a Salesforce chatbot where a person is talking with a chatbot that's connected to a company Salesforce system. And when you talk to it, at some point, you need to access some restricted information. And you say, well, can you give me the phone number of a specific client, for example? And it's going to say, well, you need to log in to proceed. And here we're supporting OAuth. So we're actually opening the authentication inside of the different system. It can be integrated with OAuth or any other provider. So actually, every step you can say whether this step is protected and whether it requires authentication. If your step is protected, then you need to define. So when, for example, you put your username and password, you're getting back to the conversation. And now it says you're now logged in. And now the actual cognitive flow is using your access token to make the authorization to access the other system. So right now, we are calling it supervised learning. We are actually asking you to go and check how the chatbot performed in different situations, and to tell it which is the right situation in that time. We are actually thinking to even simplify this so that you don't have to go to the abandoned and actually have some kind of an inbox or Some other systems support this, like let's say an inbox where you see only the things that the chatbot did not understand, so that you can actually tell it what was the right decision at that point.
I was curious what kind of test you write that you're confident your bot
I think it's. I'll actually give the floor to Boyku. He's one of the architects on the team, but just to set the stage for him, we actually implemented our own framework to help you write and automate this. So Boyku, can you give us a very quick?
Yeah, we have another declaration of best case scenarios and edge case scenarios also. So we have a JSON definitions of what a full conversation would look like, and we say what bot says, what the user says, what bot says, what user says. So our test framework is impersonating the user and checks if the bot corresponds in the various allowed ways. And it raises a flag if the bot responds in an unexpected way.
So you're pretty much writing a JSON declaration for example, this is how a conversation usually looks like, and this is how an edge case looks like, and then you're running the test to see whether this is actually responding. And we are, for example, when we are making deployments of Darwin, we have 4 or 5 critical chatbots that we always test to make sure that we didn't break anything with the cognitive flow. Because one of the important things is that when you write the different steps in the Go, we don't guarantee the way the steps are going to be executed. It really depends on the conversation with the user. And that's why you cannot rely that it's going to be a water flow or a step-by-step execution. And that's why we need to test with actual real conversation to make sure that it's performing properly. And I think it is executed with Jasmine, right?
Yes, just like the unit test, it has a different suite that does the integration testing.
Yeah.
That was my second question.
Yes.
Do you have audio?
We actually support audio from the NLP perspective, but until now we haven't had use cases and cases where people were, asking us for this. So right now, if a customer comes, he's usually in the Siri mindset. He says, "Okay, you did implement this amazing chatbot. It's perfect, but it doesn't know how 2 plus 2 is, how much 2 plus 2 is, right?" And we're like, "Okay, let's step back for a moment." And actually, voice is something where we are again discussing with clients, but at that point, there are no meaningful use cases for the companies to go and do that. But from an NLP perspective, the systems that we're using do support audio. So instead of sending them text, if we send them an audio file, it's going to return us the same intents and probabilities, hopefully.
As I understand it, it's actually this declarative bots, transactional bots,
Hmm.
is kind of easier way to write to implement the decision tree to
Absolutely.
place the decision.
Yes.
How much faster? You probably mentioned that. So
Yeah, I mentioned that it is 15 times faster in terms of time, in terms of development time. So, for example, some of our competitors, when we were presenting to a client, they said, "Okay, the customer said this is our use case. We want this use case to happen. How can you implement it?" And the shortest time after ours was 2 weeks. They needed 2 weeks to go and implement this, and we needed 8 hours. It was very different. And the reason for this is that you're actually relying on the conversational intelligence on top of us. You don't do if this happens, do that. There is no if then in the whole conversation. And one of the things that we're also right now working on to make this smarter is that we're actually trying to learn from the best case scenario and from the shortest path to the goal so that we can actually use this much more often. If the user is not saying exactly what he wants and he just says hi, we're going to use the one that is usually the shortest to get to the goal.
there is a trade-off because decision tree perhaps it's more robust in terms of reliability and expected result. So would you say that these transactional bots are at that point up to the case of replacing every possible case where you implement this?
Well, in our experience, yes. I mean, we have seen all kind of transactional chatbots being implemented in this approach instead of the decision tree. And I would not say that the decision tree is robust because there is so much code that you need to write for this decision tree. If you have 5,000 lines of code, and if you have 200 lines of definition, given that we don't break, which we are trying not to break, it's much more robust. I would say that Darwin is much more robust. And the other important thing is that when you are thinking about the scenarios, there is always a scenario that you're going to miss. And from a customer perspective, the hardest thing about the decision tree is that when you talk to the chatbot, you're asking the user to navigate the decision tree. You're getting into a certain node, and then you're drilling, and then if the user wants to jump to another node, he needs to usually restart the conversation. Just as the example initially that I showed you. Because this is the fastest way to get outside of the context. Anybody else? Sorry. Mm-hmm. Yeah. No, we are actually, this is something with Darvin.ai that we didn't want to come up on our own. We are actually using with AI, which is the Facebook natural language processing provider, for two reasons. First of all, with AI, behind the scenes, he supports more than 55 languages. In terms of language support, it's one of the richest out there. But behind the scenes, we have a provider for the NLP. So from the NLP perspective, you can go and put API AI, which is now motion flow or something like that, not something else. You can actually change the provider if you need to. You can actually go and base it on an open source NLP like Spicy. It is one that's based on built in Python. You can go and deploy it, train it on your own, and if you want, you can hook it so that the data doesn't go to Facebook if you don't want to. For certain steps, you can say, well, I want these steps to be private, so that it never is going to leave. First of all, it's not going to be used in the NLP so that this data doesn't leak if it's a credit card information, and we're not going to store it in the conversation log. You're going to just see some stars where the sensitive data is. So we're trying to use an external provider, but still provide the ability for the developers to control what kind of data goes outside our system.
Regarding the automatic learning, as I understand, you are checking the button conversations to make it better.
Yes.
Are you working with the non-button conversations where you couldn't find the fastest way to reach the information or the intent, but after a few iterations of questions you found the intent?
Mm-hmm.
Do you use the initial request of the user to automatically teach your machine that it is also a viable question?
Yeah. Absolutely. It's actually a very good question because in terms of a success metrics and metrics that we're looking after, one of the most important things is how many steps required for the user to complete the conversation. And if a conversation has 5 steps, obviously you're looking for something that is 5 at most or less. And we are actually, this is one of the metrics that shows you how far you are from the optimal point. We're actually the less steps a conversation needs, the better. And this is some of the metrics that we're actually keeping track on and showing you so that you can see how efficient the specific training for a given conversation is. And then even though maybe all conversations are successful in a given, let's say, conversation, you can go and look at all, if it was like, it needed 150% of the steps. So if it had, let's say, 10 steps, the people needed 15 steps to complete this. You can actually see what's the reason and go and look at it. So in terms of an automatic behind the scenes, we are trying to optimize the shortest path, but in the shortest path, it is limited by the way you have defined the questions and understanding. So from that perspective, you need to still manually go and tell it the right situation or fine-tune the way you're asking the question. Because it might be a problem of how you ask the question. Right. Yes, there is. You can actually go to our website, talk to a chatbot, and sign up for a demo or a trial. And we're going to reach out to you, and we're happy to provide. We currently have a set of limited adopters as developers, but we're happy to include more if we have an interest for that, so that they can actually build on top of the system. And they actually are going to receive all the things that you saw with the full-blown documentation and a Slack channel for our community where they can actually get access to some of our MVPs, so to say, for the product. Sorry.
So, two small questions, I believe. The first one is why .NET over Python, to say the least. And the second one is, what kind of architecture do you use?
So,
Microservices or just monolith?
I think you know the answer on that one. But so first of all, on the .NET and Python, when did I mention .NET? No. So right now, behind the scenes, we have a couple of things that are on JavaScript, on Node.js. We also have a couple of things for the NLP that we are testing with the external providers that are on Python. And in terms of architecture, everything is microservices behind the scenes. We are, trying to deploy rapidly all the different parts without breaking anything. So, as I said, we're pretty much deploying 5 to 10 times a day if we need to, so that we make sure that everything we do is constantly up and there, and all the chatbots that are out there are using the latest code. And that's because of this rapid deployment. We need these kind of tests for this, and we are thinking about open sourcing the testing framework because it's applicable to any kind of a chatbot that you build. Let's go with the last question so that we don't keep you here. I know it's the last session. Okay, the last question.
If you're going to redirect the chat to real person when the conversation made some condition.
Yes, exactly. Very good question. This is a very common scenario. We have a step. The success step is stay silent. And you can train the chatbot to actually, if the user says, as I said a couple of minutes ago, for example, I want to talk to a human or I want to talk to an operator, you can actually ask it, are you sure about talking to an operator? And then if the user says yes, then you can actually notify an offline person by sending in an SMS or any way you want that somebody is waiting online to talk to the user. Then the chatbot at that point, when it reaches this step, is going to stay silent for a specific amount of time until the solution is resolved by a person. It is continuing the same way. So if you're using Messenger, what happens is that for Sheriff Clinic, for example, the chatbot is notifying their contact center with a webhook. So this is the success of the contact an operator case. It notifies their system, and then a person from their team is actually logging into Messenger and sees where the conversation is, and it continues the conversation by a human, and the chatbot is just staying silent so that it doesn't interact with the conversation. Okay, thank you for spending the time today, and thank you.